Okay, y'all. So today we're just doing review. So I hope you all had a chance to look at that review sheet that I distributed. If it was useful, you don't have to stay tied to that, but basically whatever questions you have, I'm happy to go through. So just as like last semester, I'm counting on you all to ask you, what you're confused about, or even if you're not confused about it, if you want me to go through it, have to do it. But
Definitely, I'm wondering about the table of means. If you go through those. It's number 6.
okay, first things first, let's figure out what these contrasts are doing. So let's look at A1 here. What operation does contrast A1 represent?
Is it group 1 versus group 2?
Cool. Perfect. How about A2?
Group 1 versus group 2.
Great. And B1?
It's group 1 versus group 2.
Okay. What else should we know about these contrasts besides what they're comparing? Right. Perfect. So the reference group is 1 in each case. Why, if we're trying to think about how to construct a table of means, why would it matter what the reference group is?
Equals 0.
Yep, and that helps you find, yes. Great, so that's the starting place. So let's look at this equation right here. This 0 is the intercept. It doesn't have any like A1, A2, A3, whatever. So
But the B only has 2 groups. Oh, did you just put it? Okay.
yeah, you're right. Sorry about that. All right. So this is the intercept, and we just discussed how group 1 is the reference group in each case. So what mean does this intercept tell us?
I used to think it was the grand mean.
So that's a good thought. In some cases, 0 does represent the grand mean, but that's only with a certain kind of contrast. Does anybody remember what kind of contrast would be true of? POCs, because you end up centering the contrast. That's what the centering does. It makes the intercept grand mean. In this case, though, we have reference groups, group 1 and group 1 in each case. In reference group tells you what the intercept is, how to think about the intercept. So given that, what mean does the 0 tell us?
So the mean of group one,
Group 1 on which variable?
A,
A and?
1 on B.
Yep. So we look here, we can fill in a 0 there. So that's our starting place. So we just talked about how A1 represents group 1 versus group 2. So how can we use that information plus the coefficient for A1 to find another mean?
can you repeat that?
So we talked about how A1 represents group 1 versus group 2. So that's one piece of information. This is the coefficient for A1. So how can we use the interpretation of the A1 contrast to find another mean on this table?
Would you subtract group 1 from group 2 at A1, at level A1? The-
Sure. So I suppose I could say,
and multiply by 3.
sorry.
So subtract 0 from 1 and then multiply by coefficient 3.
Sure. So that would be one way I could do it. I could say A1 equals group 2 minus group 1. I could plug in 0 and 3 here. That would give me 3 for group 2. Another way you could do it if you didn't want to go through the algebra, that sort of fits how we thought about contrast all along, is you could say, well, this A1 tells me how the means or the predicted value changes as I go from group 1 to group 2. So I increase by 3. So I add 3 to this, that would get me 3.
Can you repeat that one more time?
Sure. So the coefficient for A1 tells me what happens to my predictions as I go from group 1 to group 2. This 3 tells me as I go from group 1 to group 2, I increase my predictions by 3. So 0 plus 3 equals 3.
Isn't there a plugging way?
Yeah, so that's just what I showed. You could say the coefficient for A1 equals group 2 minus group 1. That would be 3 equals group 2 minus 0, and group 2 equals 3. Suppose I could use the entire regression equation if I wanted to. Well, it would be a little bit. I think this way's a little bit clearer.
So why wouldn't that 3 be for group 2 of B1?
Right. So this is an interactive model, right? So the reason that matters is that in an interactive model, we allow the effect of A1 to vary across levels of B. We also allow the effect of A2 to vary across levels of B. Right now, we're working at group 1 of B. Later, we'll get to group 2. But we can only work out, we have to start with working out group 1, what happens within group 1 of B, because this is an interactive model. Does that make sense to everybody? let's try another. So A2 tells me what happens as I go from group 1 to group 3. So someone used that information combined with these coefficients up here to fill in another mean.
So would it be 1?
What would be 1 exactly?
B1, A3?
Yep. So this one tells me right here that as I go from group 1 of A to group 3 of A, I increase my predictions by 1. I go from 0 to 1. Right. So when I asked before I go on, any questions about that?
In this dummy coding situation, your coefficient of A1 and A2 are going to always represent the change between the two coefficients, right? Because it's always 0 and 1.
Correct. Correct. Dummy codes always represent pairwise comparisons. So the pairwise comparison that is represented is determined by what the reference group is. So the reference group is group 1 in this case, and whatever gets the 1. So these are always going to be pairwise comparisons. How you specifically interpret the pairwise comparison depends on the other side of the model. So if your pairwise comparison, or your dummy code rather, is interacting with somebody else, or something else, you have to interpret that pairwise comparison at a specific point in the model. In this case, we're interpreting everything at group 1 of B. Is that good? Let's try another. So you all said that the coefficient for B represents what happens as I go from group 1 to group 2. Remember, this is an interactive model again. So how can I use that information to fill in another mean here?
So the coefficient of the 2B1 would be the change from group 1 to group 2 for A1. So we go from 0 and then we add 2. So the B2, A1 is 2.
Perfect. So to restate what you just explained, when we're thinking about what happens to B, we have to think about where we are on A. We're on group 1 of A because that's the reference. So this 2 right here tells me within group 1 of A, as I go from level 1 of B to level 2 of B, I have to increase my predictions by 2. If I'm increasing my predictions by 2, I go from 0 to 2. Does that make sense to everybody? So once again, to reiterate, I have to interpret what's happening to B at a particular point in A. I'm interpreting everything at level 1 of A because that's the reference group at 0. So the coefficient for B tells me at level 1 of A, if I go from group 1 to group 2 of B, I have to increase my predictions by 2. Does that make sense to everybody? Questions? Someone tell me one way to interpret this -1. How am I supposed to understand that that -1 right there for this product group?
The relationship between A1 and B1 is decreasing. Let's try another one. Like the slope of the relationship between them is decreasing then.
Yeah, so it tells you what happens to a particular coefficient. One way to understand it is as I go from group 1 to group 2 of B, the coefficient for A1 decreases by 1. So one way to understand this is it tells you if I change B, what happens to the coefficient for A1? That's one way. Second way is it tells you what happens to the coefficient for B as I change on A1, as I go from group 1 to group 2 of A. So it tells me as I go from group 1 to group 2 of A, the coefficient for B1 decreases by 1. Does that make sense? There, go ahead.
So on A2, B2, it's a negative 1.
A2, B2, negative 1. So, okay. This is the coefficient for A1 is 3. This tells me that if I go from group 0 or group 1 to group 2 of B, that coefficient goes down by 1. So how could I make it so that this difference decreases by 1 as I go from here to here? Subtract 1 from, yeah, so that difference is going to be 2. How do I make it so that as I go from here to here, that difference is 2? So this difference right here is 3. This difference right here is 2. I made it so that as I go from level 1 of B to level 2 of B, this difference right here has decreased by 1. Or another way to think about it is that this difference right here is 2. This difference right here is 1. I've made it so that as I go from level 1 to level 2 of A, that this difference right here has decreased by 1. So remember, one way to define interactions is that it's a difference of differences, right? So it's like this difference right here minus this difference right here. It's 3 minus 0 minus 4 minus 2. I guess it would be these reversed, but I'll do it the right way. It's 4 minus 2 minus 3 minus 0. That would be 2 minus 3, which would be negative 1. I need to put a number right here that makes it so that as I'm going from here to here, for example, that difference is decreasing by 1, or alternatively, as I'm going from here to here, that difference is decreasing by 1.
I get that. Just to me, it seems like it's hard to intuit how to get there. Maybe that's because I'm just kind of used to using some sort of formula or equation to get it, but here it seems we just have to kind of think about it.
It involves like puzzling through what's happening in the table of means. So yeah, it's this particular question asks you to reconstruct a lot. You can imagine that if I were asking something similar to this, it would probably be stripped down somewhat.
Could you start at the beginning again? Not like the very beginning, but just for that one
the negative one coefficient.
Sure.
I think that.
So one way of thinking about this -1 right here is that it tells me what happens to the coefficient for A1 as I go from group 1 of P to group 2 of P. The coefficient for A1 right now at group 1 of P is 3. We've just worked that out. I need to set things up so that the coefficient for group 2 of P, this thing right here, this difference right here, is 1 smaller than it is up here. So up here it's 3, up here it has to be 2. What number can I put in here that makes it so that the coefficient at level 2 of P is 1 smaller than it is up here?
I'm not sure with that. I'm so sorry. I like got the difference thing, but.
Okay, so if it's 2, if that's what I, yeah, go.
Okay, so the reason that I'm like confused is because if we keep saying that it's 1 smaller, and so when I'm thinking 1 smaller, I'm like 3 minus 1. And I get that the interaction is different of differences, but this feels like really crazy mental gymnastics that like would take me like an hour to figure out. And I just think, I don't know, I'm just really struggling to follow this. And like I understand what you're saying, but I just feel really not confident in my ability to do this on an exam, which is why I'm very stressed and seeing a lot of emails.
Okay.
Is there a way to plug numbers into that formula to get that value?
I mean, one way you could think about it is that the interaction is -1 equals, well, a difference of differences. So it would be say x minus 2 minus 3 minus 0. I would really prefer not to think of this in terms of formulas, because what the kind of understanding that I want you to get is like, how do I connect some output that I get to a table of means? So I don't necessarily want to give a formula because, but you know, for the purposes of like, if it does help you understand what's happening here, then maybe that's good. So that would give you -1 equals x minus 2 plus or minus 3 that would give you x equals 4, which is what we had.
So maybe it's that -1 isn't telling you about the coefficient, but it's telling you about the difference.
It's telling you what happens to this coefficient, the 3, as I go from group 1 of B to group 2 of B.
Okay,
This coefficient,
that's where I'm getting lost. So like -1 is supposed to be telling you about what happens. I'm so sorry if everyone's not lost. But I I just keep thinking that it should be 2, like in that explanation, because I get like the difference of differences thing, but I'm confused that -1 is representing what happens to A1 as you go from group 1 of B to group 2 of B. Because I'm thinking if it's -1, you subtract 1 and it should be 2, but it's not, it's 4.
So you're right that if you subtract -1, you get stroke 3, you get 2. But that 2 is a difference. It's not a mean. So that tells you what this difference has to be.
Okay.
It doesn't tell you what the mean is.
Okay.
Yes, sir.
So it's supposed to be 0, 3, 1, right, before you erase it? In the equation.
Oh, yes.
So if we're trying to figure out the A3, B2, knowing that the last interaction is +1, so if we know that, then we know that the difference has to be 1 more than 3 minus 1. So
Correct.
would the last number there be 1? Because 4 minus 1 is 3, 3 minus 1 is 2, and so that difference would be 1 more.
Okay, so A2 tells you this difference right here, these two numbers. This coefficient right here tells us that that difference has to be 1 greater than it is over here. So before the difference was 1, now the difference has to be 2. What number would have to go here in order to make this difference 2? Right.
Which difference is that? Oh, it's a 4 versus 4 minus 3 is 1. Wait.
So, can I try to interpret the -1?
Sure, yeah, go ahead.
That's saying the change from level 1 of A to level 2 of A at group 1 of B compared to the change from group 1 and 2 of A at level 2 of B is -1.
Correct. So again, these interactions, these product terms, they're differences of differences. It's how does the difference between, say, these two numbers compare to the difference between these two numbers? It goes down by 1. Or how does the difference between these two numbers right here, compare to the difference between these two numbers? Or to go back to the second product term, where maybe you were getting tripped up. This product term right here tells us how does the difference between 2 and 0 compare to the difference between 4 and 1? Well, it goes up by 1. We go from a difference of 2 to a difference of 3. Or alternatively, it tells us how does the difference between 0 and 1 change if we go here? Well, the difference between 0 and 1 is 1. The difference between 2 and 4 is 2. Goes up by 1.
So you can do it using the equation.
Yeah.
So like the -1 coefficient, you do that and reduce the A1 coefficient by 1. It's 2 is A1, and then get rid of everything else except for the 2 and B1. And you plug in 1 for B1, and that equals 4.
Right. So you could set up the equation like this, where you have a missing number, you have an x, and you just write out what the difference of differences is, x minus 2 minus 3 minus 0, and then you can solve for x. That's fine. That would get you there too. The way we've usually talked about in class is, we think about these interaction terms as differences and differences. How does the effect of one variable change if you increasing it on another? Does that clarify things at all?
I'm starting to get it. I just really struggle with the logic of getting there without plugging the things into.
I think one of the points of confusion is that these coefficients tell you how differences change, not how one mean changes. So they don't refer to any one mean, they refer to how a difference in means changes. How are we doing?
Are you recording this?
Yes.
I mean, you can go the other way too, from the table of means to the coefficients, right?
Correct.
I don't know if that's helpful for anybody, but I mean, we could run through that as well.
Oh, yeah.
Get rid of the coefficients and work from the table of means to say what's the other way.
Absolutely. So let's start simple. We're thinking about this right here is the comparison between level 1 of A to level 2 of A at level 1 of B. So the coefficient that represents that is this one right here. The way we get this 3 is we take 3 minus 0 is 3. This right here tells us that same A1 coefficient, but at level 2 of B, which isn't represented anywhere in our equation. In order to figure out what this, the coefficient for the interaction is, we could think, well, the A1 coefficient before is, we go from 0 to 3, which is 3. It becomes, we go from 2 to 4 is 2. It decreases by 1. Were you going to say something back there?
No.
Okay. Okay. Unless I hear otherwise, I'm going to move on to the next question.
Can we run if people want to, I don't know, can we run for this for something crazier, like polynomial contrast, or
I'm not going to ask about polynomial contrasts.
how about something with like 6 groups?
I'm not going to ask about 6 groups. I may ask as many as like 4 or 5. I'm not going to go out of control. I want it to be doable in the constraints of an exam.
Okay, so we're just gonna continue with dummy codes, this type of a problem.
So I could ask about dummy codes. I could ask about plane orthogonal contrast, but I'll make the math nuts. I don't want you to have to use calculators.
Because it's gonna change with the POC, your intercept's gonna be,
The intercept would be your gradient. Yeah.
numbers are gonna be different.
So you have to pay attention to what sort of represents.
It's literally almost.
I mean, this has been true last semester. It's true this semester.
I know,
That concept is not new.
it's like Jaws 2.
All right. Another question. What would you like me to read? Might have noticed throughout the semester, I think it's important to be able to think about different representations of the same information. That, you can imagine you ask questions like that The reason I think that's important is that that's what you're doing if you look at output and try to think about what it means, or look at graphs and think about what it means. I do think that's an important skill. So first things first, what does A1 represent?
Group 1.
Group 1 versus group 2. What does A2 represent? Group 1 versus group 3. And group 1 is our reference group. We're now working with a quantitative variable, that's P. And in class, when we visualized this sort of problem where we have one categorical variable and one quantitative variable, how did we represent that? Let's start with a simple problem. If we have a dichotomous variable, which is comparing two levels, and a quantitative variable, how do we usually represent that?
Two jitter scatter plots.
Yeah, or we could do it on the same graph. Might look something like that. What changes if we add a third variable? Just add another one. So, okay, that's the general structure of plot that we're going to be working with, right? We're going to have a plot with 3 lines. So our task is to figure out what those 3 lines are. So, let's think about that first line. So, well, first of all, what does this 1 represent right here at the intercept?
Group 1.
It represents group 1, and what's happening with B? It's 0, right. So the intercept is always the predicted value. That's 0 on all of our predictors. 0 on all of our predictors represents group 1 of A and 0 at B. And it's -1. There's 1 point. This is going to be the intercept for our line that represents group 1. How would we find the slope of group 1? What makes you say that?
Just guessing from what we did last time.
That's fine. All right, so this is an interactive model, right? That means that you have to think about this coefficient in terms of where you are on B. So this tells you how the comparison between 1 and 2 changes if I increase a unit on B. This right here tells me well, what's happening to B at level 1 of A. So in a sense, that's what we're looking for. That tells us if I'm at 0 on level 1 or 0 on A, which is level 1, what's the slope for B? How does B change if I increase the unit on A? This number right here is exactly what tells us the slope of B, which is what we want to plot here, at 0 on A, which is level 1. The slope's 1, right. So that's one line. How would I find out? Yeah, go ahead.
We're missing that coefficient.
Are we?
Yeah, it's 2A1 and then plus 1 B2.
Oh, thank you.
Hey Patrick?
Yeah.
On the study guide, you have like the A1, A2, and B, and like G1, G2, G3 at the different levels, so they're like different. It's like G1, G2, G3 at level A of 1 and 0. Does it help to do that before we do the slope step, or is that just for?
I'm not sure what you're talking about. Can you direct me to a page?
Yeah, question 7. Maybe I made that, and I might have made that actually. Take it back.
Okay.
I did that.
Okay.
There's no worries. That would make it more confusing.
So how could I find out what the intercept is going to be at level 2 of A? So as a reminder, this contrast right here tells me the comparison between level 1 and level 2, and this one tells me the comparison between level 1 and level 3.
So should the slope be 1 greater for level 2 then?
Right, so this tells me that at 0 of B, if I go from level 1 to level 2, I have to increase my predictions by 2. So we'll get to the slope in a little bit. Right now, we're just thinking about the intercept. So just to repeat, this coefficient right here, this 2, tells me if I go from level 1 to level 2 at 0 on B.
So is it 0, 1?
So yeah, it would be up here at 1.
Wait, one more time, sorry.
This coefficient right here tells me at 0 on B. So at the y-intercept. If I go from level 1 to level 2, I have to increase my predictions by 2. I'm at -1, I go up to 1. So I'm increasing my predictions by 2. Everybody start to cut that? How would I figure out how B changes at level 2 of A? Yeah.
Just that first interaction coefficient, the 1A1 times B, so it tells you that the slope of 1 times B just increases by 1 additional unit, so rather than slope of 101, it's 2 to A1.
Perfect. So this one right here tells me, again, at level 1 of A, that's the slope of B. This right here tells me how that slope changes if I go from level 1 to level 2 of B. I have to increase it by 1. So the new slope would be 2. Does that make sense to everybody?
Level 1 to level 2 of B.
Of A, excuse me. Yeah, this is the only categorical variable that we have. So again, this tells me if I increase a unit on A1, I go from level 1 to level 2. What happens to the slope of B? I have to increase it a unit. 1 plus 1 is 2, so my new slope is 2. So this is going to be inexact. You got the point. Looks a little bit like that.
So line like B equals the bottom.
Yes. So the slope of my line was 1, now it's 2. I also have to change the intercept. The intercept goes up by 2. All right, one more. So A2 tells me the comparison between level 1 and level 3.
There's only one,
Yeah, that comparison is 1.
so would it be 0?
Exactly. So the intercept was -1. I have to increase it a unit as I go from level 1 to level 3. That means that the new intercept is at 0, at the origin. And then how would I find out what the new slope is at level 3 of A?
The interaction term tells you it's gonna be 1 less than the slope was for A1.
Correct. So this -1 right here tells me the slope for B goes down the unit as I go from level 1 to level 3.
So would it be 1 again, the slope?
We're looking at this coefficient right here. So this is the slope of A. This is what it is at level 1. Sorry, this is the slope of B. This is what it is at level 1 of A. So if I decrease the slope a unit, it goes to 0. So I end up with a flat line. Let me say right here, both of these questions are a little bit more complicated than what I'm expecting you to do tomorrow. Although you might expect that the questions might have a similar structure, they're just a little bit skimmed down. I certainly will ask you to go from one representation of the data, like a regression equation, to something else, like a table of means, or maybe a graph to a table of means, or maybe a graph to a regression equation. I do want you to be able to make those connections.
So here, the two A1 and the one A2, those are representing the intercepts.
A1 represents what happens to my predictions if I increase a unit on A1 at 0 of B2, or at 0 of B. You can think of it as the simple effect. It's the simple effect of A at a particular level of B. That level of B is, well, would be 0. So like,
Simple effect is 2 compared to intercept.
so this 2 right here tells me if I go from level 1 to level 2 of A at 0 on B, 0 B is, we're on this vertical line right here.
So is B your 1, 2, 3?
No, this is all factor A. This is group 1, group 2, group 3 of A. B is quantitative, just numbers from whatever to whatever. It doesn't have any particular levels.
When we're done with this, can we go to number 5 on the generalized number model section?
Sure. Before I do any of that though, is there anything else I can do with that? So one way to think about what we're doing is we're holding B constant for a little while and thinking about, okay, we need to get predicted values for outcome at the various levels of A. So we're holding B at 0. That means that we're looking at the intercept, what happens to A as I go from level 1 to level 2, and what happens to A as I go from level 1 to level 3. That gets us these 3 points, all when B is 0. Then we think about, okay, what's happening to B at those particular points within factor A. So this right here tells me what happens to B at level 1 of A. That's when our contrasts are 0. And this tells me how that slope changes as I go from level 1 to level 2. And this right here tells me what happens to that slope right here as I go from level 1 to level 3.
I totally get the change, how the slope changes, but for the intercepts each line, it seems like all you're doing is -1 plus 2, and -1 plus 1.
That's right. That gets me 3 intercepts. Yeah, that's.
Can I rely on that logic?
Yeah, absolutely. So if you were given a problem like this, you have to interpret all B's at 0 on B, so they get you 3 points along this axis. This axis right here represents B equals 0.
Okay, yeah, so, yeah, I get it. Thanks.
Other questions?
5 on the generalized linear math model?
Are we okay moving on? Just want to give people another chance to ask questions on this if they have. So, question 5. Okay, we don't have to think about interactions here. That's maybe a good thing. First of all, we have to think about our coding scheme. So the question says, group 1 is the reference group. We've got 3 groups, and one of them represents the comparison between 1 and 2. The other represents the comparison between 1 and 3. So what kind of contrast are we dealing with? Dummy codes. Whenever you're thinking about pairwise comparisons, you're thinking about dummy codes. And in fact, we could just leave this contrast coding scheme up. This is the kind of coding scheme that we're thinking about. So you're asked to think about odds instead of log odds. That's the major issue here. What you're given is a table of odds, and you're asked to think about how the odds changes as you go from, say, level 1 to level 2. So first things first, we know that level 1 is the reference group. You're given the odds in the different groups. So what would be the intercept in terms of odds based on the information that you're given?
Would it be group 1?
Yes. So the intercept in terms of odds is going to be what are the odds of admission, suspension, whatever it is, within the reference group at 0, whatever 0 happens to represent. So the intercept is going to be 1.
Or no?
Yeah, let me relabel these. So, okay, in terms of odds, the coefficients represent odds ratios. They're literally ratios of odds. They tell you by what number do you have to multiply your previous odds in order to get to your final place. So based on that, based on this coding scheme, what do you think the coefficient for C1 is going to be? 0.5. I have to multiply the previous odds, 1, by a half in order to get to a half. Or one way to think about it is it's a half divided by 1. Okay, how about C2? Oh. I have to multiply 1 by 5 in order to get to 5, or it's 5 divided by 1.
That's the answer.
This is it.
So you don't multiply by the 0.5, like 5 times 0.5, you go back to the OG, back to the original, like to get to C2.
To get to C2,
No, so you got 5 for C2.
Yeah.
So you have to multiply the last odds by the original odds, not the previous one.
Yeah. Odds ratios, they're literally ratios of odds. So it would be the odds within group 3 versus or divided by the odds within group 1.
Because that's the reference.
Yes.
Okay.
Can we switch it up a little bit, when using this format, like make group 1 like equal 3 or something?
Sure. All right. So if group 1 is 3, what would be the intercept? 3. The coefficient for C1 tells you by what number you have to multiply 3 in order to get to 0.5.
0.5 divided by 3.
Yeah, so it would be a 6th, or it would, so that would be, yeah, 0.5 divided by 3, multiplied by 2 to get a nice fraction. So you have to multiply 3 by a 6th in order to end up at a half. How about C2?
1 2/3.
Sure, 1 2/3 or 5/3. It's the odds in this group divided by the odds in this group. It's similar to what we'd be doing if we weren't thinking about odds, if we were thinking about log odds, we'd be doing subtraction here instead. Multiplication and division are sort of the multiplicative versions of addition, subtraction. Half minus 2.5. Or another way to think about it is it's 0.5 minus 3. And then C2 tells you what number do you have to add to 3 in order to end up at 5? 2. Very similar process.
Or there's another graph on number 2, the generalized linear model. That log odds equation.
Yep. Sorry, any other questions on this? So I'm just drawing reference lines at 0, half, and 1. And this is a reference line at x equals 0. So in log odd space, when you go from log odds to the probability space, things get transformed in a funky way. One important reference point to think about is that an intercept of 0 in log odd space corresponds to a probability of a half, 50/50. Kind of makes sense. It's halfway between the minimum value of probability and the absolute value of probability. So we're going to go through here. I asked you to draw an approximation, so I didn't really care if the numbers completely matched up. But so another difference between log odds and probability is that we end up with this funky looking curve that has low slope values, slope increases a lot, and then it decreases a lot. Our probability is still increasing. As x increases, we know that from the positive coefficient for x. So our logistic curve is going to look something like this. I didn't care if the numbers exactly matched up. But it is going to go through when when x is equals 0, it is going to go through that midpoint, halfway the distance between the minimum value probabilities and the maximum value. And it's going to go in this direction as opposed to this direction.
So that would be the case of x for negative, for the coefficient of x for -1.
Yes.
So what does that mean for this graph?
This means that as x increases, the probability, whatever we're looking at, is decreasing. And the fact that we have almost a flat line over here as x is getting smaller means that the probability is decreasing by a small amount at negative values of x. At x equals 0, the probability is decreasing the most it's ever going to decrease. And then at large values of x, the probability is decreasing by a small amount again. The reason that happens is that, well, probability can never be greater than 1 or less than 0.
What if our equation was 3 plus 2x?
So I'm still going to have this reference value. So the 3 means that we're shifting over where we get that probability equals a half. It's going to be somewhere over to the right. So if this were 1, our logistic curve would look kind of like this. What the 2 means is that the logistic curve increases faster. So we get a steeper rise by some amount. I'm not going to expect you to know by how much, but that's generally how the relationship is. If instead the x were a half, the rise would be less steep. It would be something like that.
Why did you draw it opposite on the previous question? I didn't catch it.
Sorry. So if I made this 0 plus -1 times x in log on space, what that means is the logistic curve goes in the opposite direction. Probabilities are decreasing as we're increasing in x. Other questions on that?
Can we maybe quickly go through number 5? On the section. So creating a coding scheme for variables.
Oh, the next generation drug? Okay. So the hypothesis is that my drug is more effective than its competitors, and its competitors will be equally effective. We've got 3 groups. I'm just going to say group 1 is my drug.
You have 4 groups, right?
Oh, sorry. Group 1, 2, 3. So I have 4 groups total, right? Okay, how many contrasts do I need to have to represent a 4-group design? It's the number of groups minus 1. So I'm saying that my drug is going to be most effective. The other drugs are going to be all equally effective and less effective than my drug. So I need to be able to assign numbers to each of these groups. So what sort of numbers would represent that hypothesis?
3/4 and then -1/4, -1/4, and -1/4.
Great. 3/4, and then I have to assign the same number to everything else. But that's not enough. I need to have these residual contrasts. The residual contrasts represent everything else that could be happening with my groups. So can someone tell me what else, what's one example of something else that could be happening with the comparisons between these groups?
One is different from 2 and
1 could be different from 2 and 3. And what would the numbers be that would represent that idea?
0, 2/3, -1/3, -1/3.
Perfect. And then what would be one other thing that could be happening between these groups?
2 and competitor 2 and 3 could be
These two could be different from each other, great. And then what would be a set of numbers that represents that idea?
0, 0, 1, F.
This type of coding scheme has a special name. Does anybody remember what it is? Helmert. These are Helmert contrasts.
So how can you imply then that competitor 1 and 3 are different? Why don't you need to do an additional test?
1 versus 3.
Yeah.
So this contrast sort of captures part of that idea that 1 could be different from 3 because these two have different numbers. And then this contrast captures the rest of that. Another way that I could have constructed this coding scheme is, and it's perfectly fine to do, could have directly compared 1 and 3. I guess I think there might be a way to like directly and then directly compare these two and then get a residual, but it's definitely easier to do it this way. So I could have constructed a contrast like this, where I have more of that comparison between 1 and 3, and then done another one like this. That would be fine. In general, with contrast, there's often multiple ways of constructing them that make some sense, especially if you have one focal contrast that like captures your main hypothesis and the rest you're treating as residual contrasts. Any set of other residual contrasts are equally valid. Any questions on that? All right. If you have more questions, feel free to email me or come to my office hours. Happy to field other questions. So yeah, if something is confusing as you're studying, feel free to contact me. So that's it.